Welcome back, GED scholars and math warriors, to Shape Raiders, and this is Raid 2, Circles of Doom and the Perimeter Pitfall. If you missed the first video, Raid 1, which talked about plane figures, make sure you check out that video. Also, don't forget to visit gedtalk.com/resources to download free worksheets with the answers. And remember, folks, if you encounter a problem with the problem on a worksheet, please make sure you reach out, and you can do that through gedtalk.com, or you can just go ahead and visit the accompanying video the worksheet belongs to. Drop a comment, let me know you're struggling and you would like an example explained to you. So let's go ahead and get into Raid 2, Circles of Doom and the Perimeter Pitfall. So first up, we're going to talk about perimeter of a plane figure. And if you're like, what is a plane figure? Please make sure you watch Raid 1, the first video in this series, to better understand what a plane figure is. But as you can see from the screen, a plane figure is a square, a rectangle, a triangle, a trapezoid, a rhombus, and these are all plane figures. It's not 3D. And so when we talk about perimeter, we're talking about the distance that goes around a figure. So as you can see with this first image on the left of the square, the white dots, I'm trying to represent the idea that you would be basically counting how many steps, what is that distance to get around this entire shape from, if you're starting in the upper left-hand corner all the way around. And so in order to do that, we are going to add the distances. And so for the square, we see 3 and 3. Well, we know about a square that square has 4 sides that are exactly the same. It has 4 90-degree angles as well, but the sides are all the same length. So the fact that there isn't a 3 on the top or a 3 on the right, that's okay, because I already know, hey, it's 3 on the left and it's 3 at the bottom. This is a square. And if you're like, well, how am I going to remember that the perimeter of a square is me just either adding the sides all up or multiplying one of the sides, 3 in this example, by 4, because there's 4 sides? You don't need to worry, folks, about memorizing formulas, because you will receive, as you can see from your screen, the GED Math Formula Sheet and explanation. And so you can see at the top where it talks about the different formulas to find the area, and we're going to look at area in a moment. But notice right here, folks, this is perimeter, and this is what I copied. I took a screenshot of this and I pasted it on the slide, but you're going to receive this sheet when you go and take the exam. If you're like, well, I'm going to test from home, you will receive a digital version of this formula sheet. So just know that these formulas, you don't need to worry about memorizing, because they're giving this to you when you go and take the exam. So because you don't need to memorize the actual formula doesn't mean that you shouldn't understand how it reads. So on the formula sheet, if you can see, it says P equals 4x, and it's 4 times whatever the side is. And so this example, we have 3. So I would do 4 times 3. The perimeter of the square is going to be 12. If you're like, I don't want to multiply, that's okay. You would just add 3 plus 3 plus 3 plus 3, and you're going to get the same answer, folks. And don't forget, you have your calculator, so make sure you use your calculator to speed up some of these more easy questions that you'll see on the exam. But let's go over next to the rectangle, and we see that the rectangle down here, the formula reads P, which is perimeter, equals 2L plus 2W. So if you're like, okay, well, what is the L? What is the W? Well, the L is going to be length, and the W is going to be width. And if you're like, well, I don't know if the 9 is the width, or is the 9 the length, or is the 4? Guess what, folks? It really doesn't matter, because look at the formula again. It says P equals 2L plus 2W. And like this square that we were just talking about, and we figured out the perimeter, you know that on this side of the rectangle, that's a 4. And you know the top is a 9, because that's how rectangles are. We learned this in that first video where we talked about plane figures and how their setup is. I know that all I need to do is add 9 plus 9. And what is that? That's actually saying 2 times 9. Well, that's either 2L or 2W. It doesn't matter, in all honesty. And then 4 plus 4, which is the same as 2 times 4. And then when we pull up our calculator, we have 2 times 9 plus 2 times 4. And let's hit enter. And what do we get? We get 26. Make sure you understand, for a rectangle, it's 2 times the length, 2 times the width, which is basically going back to the idea of perimeter. You can multiply to get the answer, or you can add. You can do 9 plus 4 plus 9 plus 4, and you're just going to, go all around and add those up. But as I mentioned, whichever way is easiest for you, multiplication or addition. Let's move on to the perimeter of a triangle. So down here, it says P equals S1 plus S2 plus S3. Well, we know that S means side. So I have side 1, side 2, and side 3. If you're like, well, how did you know this left one was side 1? It doesn't matter, folks. As long as you know, you need to just add up all of the sides. So I can do 4 plus 4 plus 4, or I can do 4 times 3, and I'll still get that same answer because each side is the same. It's the measurement, the length is 4. Please remember, you do not need to memorize these formulas to find the perimeter of these plane figures, but you do need to understand what the formula looks like and the setup of the formula. Next, we're going to look at a circle and how we can find the circumference or the perimeter. When they ask you to find the circumference, it's the same concept of a perimeter. What is this measurement around this entire circle? And so from the bottom of the screen, you can see that there is the formula, and this formula can be found on the formula sheet, folks, because when we are over here in the perimeter section, notice down here, circumference of a circle. And this is what we see, exactly what we see on the screen. So if you're like, wow, this is an extremely long formula, no, it's not. It's an interesting setup of how they decided to share it with you. The circumference equals 2 times pi times r. Okay, so the circumference is 2 times pi times r. Or if you know the diameter, this is going to be the second one, the circumference is also found by taking pi times the diameter. And if you're like, what is a diameter? So let's go over to our circle. So the diameter is the distance all the way across a circle. So from this point up here at the very top to this point down here, you could say like the North Pole and the South Pole. The distance is considered the diameter. They might show you the diameter going horizontally too. So don't think that just because I'm sharing it with you in black on the screen as a vertical diameter, that they wouldn't be able to share it with you going across horizontally, like I just drew with this green line. So D is diameter. The r, which we saw in this first formula, r is radius, and the radius is half of the diameter. And so the radius is from the center point of that circle all the way to either the right, the left. It can go vertically. It doesn't need to go horizontally the way you see in blue on the screen right now. So if you're like, well, what does it matter if I do 2 pi times radius or pi times diameter? It doesn't, folks, because the radius is going to be half of the diameter anyways, as you can see from the visual on the screen. So if they only give you the radius and they say, okay, well, the radius is going to equal 5, in your mind, you could be like, okay, well, the diameter equals 10. You can use either one of the formulas. If they only give you the radius and maybe they give it to you as like a decimal, like 5.37, and you're like, I don't want to times that by 2 in my head to get a diameter. Maybe you've forgotten that you have your calculator for some reason. Either one of these formulas will give you the circumference of that circle. So you could do 2 times pi times 5.37. And if you're like, well, I don't know what pi is, that's what they're sharing with you on the second part of the formula. On the formula sheet, they're telling you pi is 3.14. So you don't even need to memorize what pi is because they're sharing that with you right here. So in reality, it's 2 times 3.14 times the radius. Or you could do, if you decide to multiply the radius times 2 to get the diameter, you can instead do 3.14, which is pi, times whatever amount you figured out was for that diameter. So let's go ahead and pull up our calculator. So with the calculator, I want you to come down from the top 4 rows and notice that there is this key that looks very similar to the pi symbol that they're sharing with you on the formula sheet. Because guess what, folks? That is a pi key. In reality, pi is 3.14, and I think it's like 10 digits, or it might be longer than that. And so in math, especially for what you're doing for the GED exam, you're really only focusing on pi plus 3.14. So let's say, though, for example, we're going to use what we said, the radius was 5.37. So I'm going to use this formula. I'm going to say 2, and then I'm going to come over here and I'm going to click on the pi key. And then I'm going to do times 5.37. And I'm going to hit enter. And we get our answer, which is 33.74, and it continues on. If you're like, well, would that still be true if I did 2 times 3.14 times, oh, go back, 5.37? And we get 33.7236. And if you're like, wait, what is the big difference? What happens? Remember, folks, this pi key, and if we hit the pi key and I hit enter, I'm going to toggle it so you can see the decimal. When you use your pi key, it's not multiplying by 3.14, it's multiplying by 3.141592654. And so that's why when we came up here and we did 2 pi, we got an answer that wasn't the same as what we just did with the 3.14. So if you're like, well, does that mean I shouldn't use this pi key? Yes, you may not want to use it because obviously from the formula sheet, as we can see, they're telling you that they consider pi 3.14 and that's it. So as an instructor, as a teacher, I would tell my students, don't worry about this pi key. Just know that on the formula sheet, it'll tell you what pi is, which is 3.14. So let's say, for example, if they say the diameter of a circle is 15, well, the formula says pi times the diameter. So we're going to do 3.14 times 15, and you get 47.1, and that's going to be the circumference of a circle with a diameter of 15. So next up, we are going to discuss the area of these plane figures. And remember, the perimeter was the distance that you would travel to get around the shape, whether it's a square, rectangle, and we now see the parallelogram, a triangle again, but we didn't see a trapezoid, and so we're going to review that as well. And so when it comes to the area, as I mentioned, you're going to be thinking about, okay, what is the surface space? Because remember, these are plane figures. They're two-dimensional. So you're not looking for volume. Ask yourself, okay, how much space is going to be available within this shape? And we figure that out using, yep, you're right, formulas. And as you can see on the left, we have a screenshot of formulas that you will see. So if we go back to our formula sheet that you'll receive when you take the math exam, notice at the top, they start with area of a square, the rectangle, parallelogram, triangle, trapezoid, and then we'll take a look at a circle in a moment as well. And just like the perimeter formulas, you don't need to memorize them, obviously, but you do need to understand what it means, what each part of that formula is standing for. So for the square, we see area equals S2. Well, what do you think S stands for? Yeah, if you thought the side, you're absolutely right. So what we see here with this first example of the square that I decided to color in green for you, we see the sides 4 and 4 because that's a square, right? The sides are all equal. So when we want to figure out the area, we're not adding, we're actually going to multiply 2 of the sides, the 4 times the 4. That's what it means when it says S raised to the power of 2. So if they didn't even give you this bottom 4 down here, let me delete that. And it was just, they said, hey, here's your square, and one of the sides we're going to label as 4. You instinctively know, looking at the shape, that it's a square, being told it's a square, that, hey, if one side is 4, all the other sides are 4 as well. Well, to find the area, all we do is 4 raised to the power of 2. That's the formula, right? Side raised to the power of 2. And you want to make sure that if you're doing this in your head, you understand when you raise to the power of 2, it's not 4 times 2, it's 4 times 4. And then also remember that you do have your calculator that can help you out. Know that there is that button when you go down from the top, 1, 2, 3, 4, 5, the 6th row, you have your x squared. That's when you will be able to raise that value, the power of 2, and we get 16. Next up, the rectangle. And our rectangle has one side at 4 and the bottom is at 9. Well, the formula says area equals length times width. So we know that to find the area, I just have to do 4 times 9 or 9 times 4. And folks, do this in your head or pull up your calculator, whatever you need to do to take care of that. That's how you figure out the area of a rectangle. Moving on to parallelogram. And so we're down here in the left corner. we see that we have the height. I have this black line drawn for you to let you know what height means, and then the base. So if you go up to the formula, the parallelogram, it says area equals base times height. So they'll give you a number as a base, and then they'll tell you or they'll show you kind of like how I'm showing you right now with the black, and that they'll have a number next to the line because the height on a parallelogram, what they're measuring is the vertex that we see here. This is a vertex. A vertex, if you come over to the triangle, is the another word for it is an apex. It's like the highest point. So the height is the vertex to the base. And then the base is going to be the measurement of this bottom side down here, which I labeled as 9. And then the height is 4. You go up to the formula, base times height. It's the same thing that we kind of did for this rectangle. So we would just do 9 times 4, and that would give us the area of this parallelogram. Moving on to the triangle, to find the area of a triangle, if we're looking at the formula up here, area equals 1 over 2 or half times the base times the height. And so for the base, they'll do the same thing for you. They'll give you an amount. They will draw a line to tell you like, hey, this is the height that we're giving you, and the height might come in at like whatever number they give you. But once again, the height is measuring from that vertex, that top point that the shape goes to, all the way down to the base. So we would have 1 over 2 times 7 times 5. And if you're like, yeah, is it okay if I do height times base? Yes, as long as you remember that you need to include the fraction 1/2. And folks, like I've been saying, make sure you pull up your calculator when you need to. If you can do it in your head, that's awesome. I would just highly suggest using your calculator to check your work though. And last but not least, we have the trapezoid. And the trapezoid is a little bit more in depth when it comes to an area. It reads area is 1/2 the height times base 1 plus base 2. So because of this shape that we see, this trapezoid, we have two vertexes, this one on the left and this one on the right. And so that's basically why we're going to see that it's base 1 plus base 2. So they will give you the height, and the height should be the same. If it's a true trapezoid, the height for both of these lines would be the same. So let's pretend and say that this is 7, which means this is 7 as well. Well, base 1, because it's shorter than base 2, we need to make sure that we pay attention to that information. So base 1, they might say that this is 5, and base 2, they might say that this is 10. So then you would just want to make sure that you're paying attention to the formula, which for this trapezoid is 1/2 times the height, and we know the height is 7. So we have height as 7 times B1, which is 5, plus B2, which is 10. And then you would drop that into your calculator, folks, and you would get the area of a trapezoid. Moving to finding the area of a circle. Well, folks, like the area of the other plane figures that we looked at, even the perimeter, when it comes to these formulas, you don't need to memorize them because it's going to be on the formula sheet that you will receive when you take the GED math exam. And so area of a circle is right down here where it says A equals pi times r squared. And that's what we have on the screen right now. And so remember, folks, that you don't need to memorize the formula, but you need to understand what it stands for. So the A obviously is area equals pi. And remember that they're going to tell you on the form, let's pull that back up, exactly what pi equals. So coming back to the area of a circle, as we can see, it's pi times r squared. Well, what if they give you the diameter and they're telling you that the diameter is equal to 10 feet? And you're like, well, the formula wants me for radius. You need to remember, folks, radius is half of the diameter. Half of 10 feet is going to give me 5 feet. And so now I have what I need to pull up my calculator. That's all we're going to do right now. We're going to pull up our calculator. Let's clear the screen. And we're going to do 3.14, that's pi, times the radius, which is 5 squared. And remember, squared means 5 would be multiplying by itself, 5 times 5. Well, come over here to the left, fourth row from the bottom, you have your squared key. So you're going to click on that, and then we'll hit enter. The area, if the radius is 5, the area will be 78.5. Let's look at a multiple choice problem. So the problem reads, what is the area of the yellow portion of the rectangle? So our image of the rectangle is right down here, and this is a rectangle, right? But what they've done is they've split it, and so we know that there's a part of it that they've colored in pink for us, and then the yellow portion. And it's asking us the area of the yellow portion. So now when we look at this yellow portion, now we need to think about, okay, how would I find the area of this image, of this figure, plain figure, that's no longer a rectangle? As you can see, the side on the left is going to come at an angle almost. And so we no longer have that rectangle because part of the characteristic of a rectangle is to have four right corners. And this shape, this yellow shape, does not have four right corners. It only has two right corners. So when it comes to finding the area, and we know that the formula sheet will share the formula, so we don't need to worry about memorizing it. Now we need to decide, well, which formula are we going to use? So obviously we know that this is not a square. So I'm going to scratch out square. We know it's no longer a rectangle because the left side, it's tilting upwards. It's at a slant, I should say, and it takes away the two right triangles that we need to have exactly four. So we're not going to use rectangle. Parallelogram, okay, it might be a parallelogram. Triangle, nope, that's definitely not a triangle. But then we also had trapezoid. So this is where it's important, folks, to make sure that you know the characteristics of a parallelogram and a trapezoid. Remember, a parallelogram is a four-sided figure whose opposite sides are parallel and the same length. Okay, well, the top is parallel to the bottom, but the right side is not parallel to the left because remember, the left is kind of at a slant now. Eventually, the lines will end up intersecting. So we know that this isn't a parallelogram, and so we're left with trapezoid. And remember, a trapezoid is a four-sided figure with exactly one pair of parallel sides. And we have exactly one pair of parallel sides, so we know that it's going to be the trapezoid formula we're going to use to figure out this problem. So we see the formula right down here, and I know that the area is going to equal 1/2 the height times base 1 plus base 2. So let's identify the height. The height right here is 8. So 8 is going to be my h, and then base 1 and base 2. The 5 is base 1, and the 9 is going to be my base 2. So all I need to do now is pull up my calculator, and I'm going to input the information using the formula from the formula sheet for the trapezoid. So I can either do 0.5, which is the decimal form of 1/2, or I can click on the fraction button up here, and I can insert 1/2. Let's click on the fraction button, and I'll do 1 down arrow, 2 right arrow to get out of the fraction. So 1/2 times the height, which is 8, and then I'm going to open parentheses and then do B1 plus B2. Because remember, you guys, we have the order of operations and we need the calculator to know that we want it to follow that whatever happens in parentheses comes first. So B1 is 5 plus 9, close parentheses, and let's hit enter. And we get 56, folks. See, it's just 56. And if you're like, you know what, I would rather write everything out first before I go to my calculator, like you want to write the 8 and then you want to do 5 plus 9 before you go to your calculator, folks, you can do that too. Whatever makes it easier for you to answer these questions. So let's look at this problem, and it reads, what is the perimeter of the circle to the nearest foot if the diameter is 12 feet? So down here at the bottom below the image of the circle, we have from the formula sheet, the formula for the circumference or the perimeter of a circle. So we know that the circumference equals 2 pi times the radius, or if you know the diameter like we do, we can do pi times the diameter. And remember, folks, they're telling us that pi is equal to 3.14, not the entire pi number that we looked at earlier, but just up to 3.14. So let's go ahead and pull up our calculator again. And I know the formula I'm going to use, pi times the diameter. I know the diameter is 12. So all I'm going to do is 3.14 times the diameter, which is 12, and I hit enter, and I get 37.68. But the question is asking me to find the answer to the nearest foot. So that means they want us to round up. So I know I want to round up the 7, so I look to the neighbor, which is a 6, that's higher than 5, which means I round this 37.68 up to 38. And our answer, folks, is going to be C. Thanks for watching RAID 2 Circles of Doom and the Perimeter Pitfall. Folks, remember, part of the exam, 20 to 30% of the questions of those 46 questions that you will see on the math exam will be geometry questions. So you want to make sure you are paying attention to everything that we are offering on gedtalk.com/resources. This includes the math handouts that you can find on the resources page. We also have the math formula sheet that we've been using, and there's a link to the PDF. And this PDF is from GED folks, not GED Talk. It's the actual testing folks who are sharing this formula sheet with you. And once again, you want to make sure that you are familiar with what is on this formula sheet. So when you do take the exam, you're not surprised. You know what you're doing, folks. Keep your head up. You got this.